Welcome to the Density Video Lab. If you have not answered the pre-lab review question yet, pause the video and do that now. For this lab, you will be calculating density for regularly shaped objects and irregular shaped objects. Here's a reminder of the formula: density equals mass divided by volume. Be sure to write this formula on your lab report sheet before continuing on to part 1. Part 1 will be regularly shaped objects. The first object will be a rectangular prism. As you can see, here is the formula for a rectangular prism: length times width times height. Be sure to write the formula on your lab report before continuing on. The rectangular prism that you will be calculating density for is a DVD case for our good buddy Shrek here. On the following images, you will see the mass and the length, width, and height. Pause the video to do your calculations and then start the video again when you're ready. The next regularly shaped object is a sphere. Here you can see the formula for a volume of a sphere. Make sure you write that on your lab report before continuing on. The next two items are spheres, a ping pong ball and a golf ball. You will be calculating the densities for each and then making some comparisons. The ping pong ball is first. Pause the video to complete your calculations for the ping pong ball and the golf ball and answer the compare and contrast question on your lab report. When you're ready, start the video again. The next items will be cylinders. As you can see here, the formula for cylinder. Be sure to write it on your lab report before continuing on. And just like before, you will have two items that you will be comparing. The two cylinder items will be beakers, a small beaker and a large beaker. Again, you will calculate the densities for each and then have a compare and contrast question at the end. The small beaker is first. Pause the video to complete your calculations for each of the beakers and then answer the compare and contrast question before moving on. When you're ready, start the video again. Part 2 will be calculating the density for irregularly shaped objects. But if they're irregularly shaped and there's no set formula to calculate the volume, how exactly do we do that? We still use the same density formula, mass divided by volume, but calculating the volume is a little bit different. We use what's called water displacement. Water displacement is exactly what it sounds like, how much water is displaced. So basically, here's what you do. You take a known amount of water in a container, And then you drop the object into the container and measure the difference in the water. The difference in the water is the volume of the object. Measuring water displacement can get a little bit tricky. So here's an example. How do you actually measure the liquid that's in the container? You have to be at eye level with the liquid in the container, just like the image here shows. And the water looks kind of curved in the container, so you're looking for the meniscus, and it's the bottom of that curve. Where the bottom of the curve of that water is, that's where you take your measurement. Let's do a quick example. I have a rock, 35 grams, that's our mass. My volume of water that I'm beginning with is 100 centimeters cubed. After I place the rock into the beaker, the displacement of water is now at 250 centimeters cubed. When I subtract the two, that tells me that the volume of the rock is 150 centimeters cubed. So let's continue on with the formula. Plugging in the data that we know into the formula, our mass is 35 grams, our volume is 150 centimeters cubed. We divide that out, and our density is 0.233 grams per centimeters cubed for the rock. Pause the video so you can complete your lab report for the rock example, and then start the video again when you're ready. As you can see from your lab report, you have 3 objects that you will be calculating the density by using water displacement to determine the volume. You have a snowman, a toy car, and a lime. You may pause the video at any time that you need to. Pause the video to make your calculations, and when you're ready, start the video again. Pause the video to make your calculations, and when you're ready, start the video again. Pause the video to make your calculations, and when you're ready, start the video again. And now it's time to finish up that lab report. Good luck.